Okay, welcome to another Orbiter 2010 video. And this video is going to be the first video in a new series that I'm doing. I'm going to be going from each of the moons of Jupiter. Actually, let me say that a different way. I'm going to start off on Callisto, which is the moon that's farthest from Jupiter, and I'm going to hop my way down until I'm at Io. So there will be 4 different moon hops, and the inspiration or the motivation behind this video series is that I want to do everything with IMFD and not even look at transects. I think I now have a pretty good understanding of how IMFD works. Dimitri and I have spent a whole bunch of time recording that IMFD training series, and plus he spent some additional time with me off camera helping me out. So I think I've got a really solid understanding of IMFD at this point. And I thought one thing that would be fun to do would be to do sort of this moon hop series where I go from one moon to the next and use just IMFD. Now, this will be a little bit easier than it would be if I were, say, going from a moon of Jupiter to a moon of Saturn. That would have some different requirements. In this sense, we're basically, if you think of Jupiter as the sun, and then you think of Callisto and Callisto, Europa. I forget the order of the moons, but whatever. If you think of Jupiter as the sun, and you think of the 4 moons of Jupiter as planets, then in some sense we're just going from planet to planet, but the planets just happen to be relatively close together. So that's the idea, and I think it'll be fun. Let me go ahead and switch camera views here. By default, Jupiter doesn't have any bases on any of its moons if you just have Orbiter 2010. But I recently made a moon package for all of the outer planets, and I'll put a link to those down in the description area below. So we now have bases that we can use as our starting and target points. So here on Callisto, I've just got this base set up. And I positioned this base purposefully so that we would basically be looking at Jupiter. And as I mentioned, I don't know if you saw that Jupiter moon video that I did that was only a couple minutes long. All of the moons of Jupiter are tidally locked, so no matter what time of year it is, and no matter what year it is of the century or the millennium, we'll always have Jupiter in our forward view from this base. Okay, so let's just go ahead and get started then. And let's F8 over to the larger MFDs. They show up better in the video playback. And let's bring up IMFD over here. And I'm tempted to kind of almost do like a documentation while I do this, but I don't know if that would be interesting enough, where I bring up like a WordPad type of editor and I kind of outline, like what step 1 would be. Actually, I think I'll do that. Hopefully that won't be boring for people, but I think that having something like that will help people if they actually want to learn this process. So open IMFD, that's obviously number 1. And then number 2 is going to be, let's see, we want go to course and then target intercept. That's going to be step 1. So let's put that in, course, target intercept. And from there, we need to select our target. And again, I don't recall which moon is the next one in. Let me see, there's Io, Europa, I think it's Ganymede, is that right? Check, no, let's see. Yeah, Ganymede, so it goes Io, Europa, Ganymede, Callisto. So we need to target Ganymede. Okay, so select, bring an open IMFD course, target intercept, target the target body, Now for the 4th step, what we need to do, by default, when you bring up the target intercept program, it will find a solution for you. Now the important thing to realize is that the solution that it finds, I don't really know what criteria I don't really know what criteria IMFD uses to find the solution that it finds, but typically the one that it finds is not the best. And in this case, it actually looks like it's an awful solution, because what it has us doing, it has us leaving Callisto, dropping all the way down to the orbit of Jupiter, then coming back out and rendezvousing with Ganymede. That to me just seems very bad. It would seem to me like it would be far better if we just wait until we can warp time forward enough to then drop down from from Callisto directly to Ganymede, rather than going all the way in and coming back out. It would reduce our time of flight, for one thing, and it reduce our encounter velocity. Because our encounter velocity in this case, we would need an inward burn, or not an inward, but we would need an arrival burn of that amount to basically rendezvous with Ganymede when we got there. So our total delta V would be that number. And that's a lot. I mean, that's, even for the Delta glider, that's a lot. So surely we can do better than that. So what we want to do first is, I'm not even sure really if we want to lock the time of flight in this case, because it's so bad to start with, but that's usually what you would do, would be to then go and lock the time of flight. So that's normally would be the fourth thing to do, would be in the target intercept program, press, next until you get to TOF unlocked. Then press ++, I believe it's ++, or just plus, to switch to TOF locked. So that would be the next thing to do normally. In this case, it may not be the best thing, but we'll find out. So we have the time of flight locked. Now we want to go to the MJD, and this MJD is for the time of arrival. So 5, go to the MJD of arrival, which is under TIN, just to have that as a reference, and use plus and minus to find a more efficient time of arrival. The best time of arrival will be when the DV is at its lowest. Now, of course, you have to take into consideration, if for some reason you wanted to have a really fast trip to Ganymede, then you might want to you might not care about the delta V. You might say, well, the delta glider has, 29 kilometers per second, so I don't care how much delta V I'm using, I just want to get there as fast as I can. In that case, then you wouldn't want to focus so much on the lower delta V, you would want to focus on the lower time of flight. In this case, it's saying that our time of flight would only be 6 days. That's pretty fast, but I typically prefer to find the lowest delta V, so let's do that. So with time of flight locked and with the MJD selected, let's go forward. And I believe we have to go forward. We could go backwards and then use the date editor to rewind time, but let's go forward. And we can see our total delta V and our OV and our IV. We really want to look at both of these separately, the OV and the IV. The OV is how much it's going to cost us to leave. So it's like the, I forget what Dimitri referred to it as, but like the outward. And then like the IV is the inward, but not to be confused with like an outward and inward burn. But that's how much it's going to cost us to leave. That's how much it'll cost us when we arrive. In some cases, it's very important to look at these separately, because the arrival body will have an atmosphere, in which case you don't really care what the IV is, because you're going to use the atmosphere as a brake. In this case, Ganymede does not have an atmosphere, so we need to look at both of these, and so we need to look at the total, basically. So we're going forward, and you can see this is coming way down. We've already cut 4 kilometers per second. That's huge. Now we're down to just 8, so that's just a massive savings. I mean, you can see now we're down to 5. That's almost getting down to the point what it costs to go to the moon from Earth. Now we're down to 36. And we're just going to keep going forward till we find that low point. Now we're down below the cost of going to the moon from Earth. Now you can see it's going back up. So let's go back to that low point. Okay, it's about right there. Now, once you have the lowest DV, turn off TOF. Let me rephrase that. Once you have the lowest DV, toggle TOF locked back to TOF unlocked. Okay, so that'll be the next step. And the reason we want to unlock it is because we now that we have the best time of arrival, which interestingly enough is only 6 days here. So you can see just by leaving it a different time, we're saving a massive amount of delta V, because wasn't it before, I think it was still 6 days before, because we were looking at, instead of 56725, we were looking at like 56731 or something. So we're not even adding any additional time of flight here. We're still going to make, oh wait a minute, we're still going to make the trip in just 6 days, and we're saving 15 kilometers per second. That's freaking huge. Okay, so we want to turn off time of flight, the lock now, and the reason we want to do that is because we now want to see when the best time to leave is, because the best time to leave may not necessarily be when this came up with when we had it locked. So now we want to go to the MJD for the ejection, which is, when we're going to leave, and we want to do an adjustment here to see if we can bring the overall delta V down even more. Now, one thing to note about the ejection is that you may quickly need to ignore the MJD and just go straight to the TEJ. If we think about this in terms of transx, when you adjust the MJD here and here, it's similar to adjusting the maneuver date at a setting of rough, probably like coarse or medium. But when we come down to here and we do the adjustment on the TEJ, we're adjusting like fine, super, ultra. We're getting down to that level of adjustment. Okay, so then once you have the lowest DV toggle time of flight off, now go to the MJD of the ejection, which is under the TEJ, which you can see here, which is under the TEJ on the left, and use plus and minus to find a more efficient time of departure. Typo. Okay, so now let's do that. And again, watching the delta velocity here, minus is raising it, so we'll go back to where we were. Now plus, that took it down a little bit, I believe, yeah, just by a few meters per second. So we'll go plus again. Got us a few more meters per second. And now it's going back up. So now instead of saying, okay, victory, yay, we're done, it can also help to come down and do these finer level of adjustments. So we're not getting any more benefit, even at 1x, we're not getting any more benefit out of adjusting the MJD one way or the other. But if we come to the TEJ, and we'll probably want to start with at least 10, maybe even 100x adjustment on the TEJ, because again, here we're going from like rough, coarse, medium type of setting down to super fine, that level. But when we go from here to here, if we have it set all the way to 1x, then it's almost like a hyper setting. So if we go plus, then now we've got like super or ultra, whatever the order is. And then if we do another 100x, then now it's kind of getting up more into the fine range. So let's see what happens here to the total delta V. So I'm adding in a little more time. That went up, so we know that's not right. And we go back and it's going up. Okay, that's good to know. Now, and let's make a note of that as a step. Once you, after you have adjusted the MJD and found the lowest DV, change to the TEJ variable and make adjustments to ensure the dV is actually at its lowest value. Note that when you adjust the TEJ, you will probably need at least a 10x setting, and in some cases you'll want to start with a 100x setting. Now for the next step, what we want to do is we want to go back and forth between the TEJ and the TIN in order to just make sure that that value is at its lowest point. It can seem a little tedious, but you can find in some cases that you can actually save several hundred meters per second. I mean, we may not get any benefit in this case, but in some cases I've seen where when you go back and forth between the two variables, you end up bringing this down another 200, 300, 400 meters a second. It can be significant. So the next step is to then go to the TIN. And actually, the way I'll phrase this step is now alternate between the TIN on the right and the TEJ on the left to dial in the absolute lowest dV. And we'll word it like that. Okay, so with the TIN selected, and again, we'll stick with the 100x for now just to see. Plus, that's not helping. Minus, that's not helping. So let's go to 10, because we may be making too big of a change all at once. You can see that came down a little bit. I can tell just, with the very little bit of IMFD intuition that I have, that we're not going to get much lower than we're already at. But we're saving a few meters a second here. So that's down to 699, and that's going to be the bottom. So let's go back to 699, and now we'll come back over to TEJ. Again, we're alternating between the two. And you just want to go back and forth until you cannot get the total dV any lower. But you can kind of tell when it's already near its lowest point. So at this point where you really don't have to bother with it. But in some cases, when you're making adjustments to the TIN and the TEJ, and you can see clearly that it's having a large adjustment, then you want to keep going back and forth. But here, there we're just bringing it down ever so slightly. There's another meter. There's another meter. And now we're probably going to go back up. No, we're still getting a little bit of benefit, so I'm just holding down the plus. And now it's going back up. And actually, something that just kind of dawned on me, we are 612,000 seconds away from the time to do the burn. So what we really should have done before we did our fine-tuning back and forth is we should warp time forward closer to the TEJ, because that's like 7 days out from the time to eject. That's pretty far out into the future. Our predictions may not be the best. So we can either warp time forward at 100x for a few minutes, or we can just use the scenario editor and we're going to bump the day forward. And you'll note that it'll have some impact on what we've come up with so far. So I should probably insert a step. Let me think about that. So we'll go to the day, and we want 1 day, 2 days, 3 days, 4 days, 5 days, 6. Now we're about 1 day, a little more than 1 day out. And that's fine. That's about where you want to be. You want to be about 1 day away from the time to actually leave. So let me actually insert that as a step. Once you have the lowest dV, unlock. Find a more efficient departure. Okay, that'll I would say right after step 7. Yeah, right after step 7. Now, if your departure MJD is greater than 1 day, more than 86,400, I guess it's probably K is the way they write it here, isn't it? Yeah. More than 8, then warp time forward until you are just 1 day from the time to leave. I should have done this as a numbered list, because if I have too many of these, I'll have to be constantly editing the list numbers. Okay, so now, we've alternated back and forth. We found the lowest number. We've warped time forward. And now we're 1 day away. But let me check one thing. Since I did the configuration between the TEJ and the TIN at the wrong time, let me just double check here, see if we can bring that down anymore now that we're closer to the actual time to leave. Probably won't make a difference, and it doesn't look like it will. There, it's going up. So now if we go backwards a bit, and I saw 4, we'll take it. Every meter per second. And then just quickly on the other side, just to be kind of ridiculous about all of this, just checking here. And we have the lowest number there, and we'll check it again this way. And we have the lowest number here. Now, if you want to be overly ridiculous about some of this, what you can now do is you can go back to the time of flight, you can lock it, because now we know that this solution is good. We know that we have what we like. And let's kind of make a note of what we have here. And you'll understand this in a second. And it's probably a good idea to do this, especially if you're trying to plan for, especially if you're trying to plan for the very best. So let's just make a note, because otherwise we'll likely forget it. We'll say that our total delta V is 2694. Okay, so now the next step, and this is kind of optional, but I think it's a good idea. Relock, let's say it this way. Okay, once you have the lowest DV, we'll say basically the same thing that we did in step 6. Once you have the lowest DV, toggle TOF unlocked back to TOF locked. Now, the reason we want to do this is because we have a really good, it's like a Hammond transfer pretty much here, close to it. And it probably actually will be by the time we get over here. But we may find that if we leave over here, we have an overall better solution, and it could be significant. So let's find out. One thing to know is whether or not we're leaving or arriving at a node. Unfortunately, there's really no way to know that in IMFD that I know of. The way that Dimitri shows me to do this is to bring up transx. And I know I said that I wanted to do this entirely without transx, but we're not actually going to use transx. We're just going to see where the line of nodes is at. That's all we're going to do here. So with Callisto as our major body, we're going to press ++ to get escape, then go forward. Then we want Ganymede. And we just need to view over to the eject plan, put in any amount of prograde, it doesn't matter. And then now we have the line of nodes. And what this shows us is that this is where the line of nodes is at. And if we can sort of transpose that in our mind from this MFD over here, we can see that, the third button up basically is where the line of nodes starts on that side, and it goes across to about here. So that means that we're leaving at a point that's not quite on the line of nodes. And something else I can do, because I have this line drawing tool, which I don't apparently have up at the moment, so let me start it. And this is just for illustration purposes. I don't recommend this necessarily as a step, although you can do it. You can download this line drawing tool, it's free, although I've paid for it. And you can bring up just the distance measuring tool is fine. And we can draw a line across the line of nodes on this side. And this is just so that we can see exactly where it's at, kind of get it lying over top the line of nodes so that you can't see the white line any longer. That's pretty good right there. And now we can drag this line over to here, and we just want to put it across the middle of Jupiter, like right there. Now we basically know where the line of nodes is at on this side, so we don't really need transx. We don't need transx or anything anymore. Now let me move this up here, and I guess we can lock it. Now, so if we leave here and we arrive here, then we're not quite on the line of nodes, and that may not matter. In some cases, it's every bit as efficient to arrive slightly out of a node. It may not be a big deal, but we can find out. So with the line of nodes now here visible, we can go back to either MJD here or MJD here. Since we have the time of flight locked, it doesn't matter which one we use. And we can do an adjustment to move time forward and just see what happens if we arrive or depart at a node. So let's do that. Watching the total delta V, you can see we're coming around. And you can see clearly here, although we're arriving at a node, we're not leaving at a node and we're having to drop way in to Jupiter, so that's clearly no good. Let's go forward a little bit more. And obviously this is awful. Even though we're leaving and arriving at a node, we're basically dropping straight down, so that's just the worst possible scenario you could have. And so it kind of looks like it may be better, it could possibly be better to arrive and leave at a node, but what would have to happen is that you'd have to probably warp time forward several orbits until the two moons were in a position where they happen to fall on a node on either side. And it's probably not worth that trouble, but just out of curiosity, I'd like to see what would happen if that were the case. Just warping time forward here. Well, I'm not really warping time forward, rather, but I'm moving the eject date forward, and you can see, you know, we're still not really getting anything any better than the 2694 that we had before. And again, every now and then you may want to check and see what your total is, even if you're not at the node, because you may find a better position. But it looks to me like we found the best, or close enough to the best, that it's just certainly not worth messing with anymore. Yeah, there's still 27 there. Let's go around a little bit more. $26.97, $26.82. So technically here is a little bit better. And that very well could be because we're leaving at, or rather we're arriving at what appears to be, no, I was going to say that's apoapsis or periapsis, but that doesn't appear to be the case. But here we're only saving, you know, 12 meters a second. Not worth messing with. And by the time we warp time forward another 6 million seconds, which is 10, 20, 30, 40, 50, 60, or 70 days, that's several months, it may be that all that resets back to nothing anyway. So I'm content that we found pretty much the best solution. So let's go ahead and bring the time of flight all the way back to where we were. And that's when the TEJ is just 86,000 or something like that. Okay, now do an adjustment down to 1. And now we'll just find our low point. And we're about right there. I think that was as low as it got, 26.94. That's what I wrote down, so we'll take it. So that's just one thing you can do to make sure that you are in fact leaving at the right time, because don't take it for granted that the very next opportunity that you find is the best. You'll find the very next opportunity that you find that has the lowest DV is probably a good solution, but you'll often find that the very next opportunity to leave is not the best, and it may not be the best by hundreds of meters per second, if not thousands. So it's always good that if you're really trying to find the lowest delta V, find what the next opportunity is, write it down, then see if you can do better than that even. So let's kind of check our notes here. So once you have the lowest delta V, toggle TF unlocked back to TF locked. Now add, let's see, how do we word it before? Now go to the MJD of departure or arrival. Since the TOF is locked, it doesn't matter which one you choose. Advance time forward and see if you get a significantly lower, did I spell that right? Significantly, yeah. Significantly lower DV at some point in the future. So that's the next step, and we did that. And okay, we're at 30 minutes, so this will be a good stopping point, I believe. And when we come back, we'll go through and kind of refine things a little bit more, figure out what we need to do to make this initial trip from Callisto down to Ganymede. If you like this part of the video, please like it. If you don't like it, hit the don't like button. Subscribe to the channel if you're not already subscribed so you can be notified when I upload new orbiter videos. Be sure to check the description down below for links. I'll include a link to my moons that I made for the Jovian system. I'll include a link to this line drawing tool that I use, and you can use this part of it for free, that measurement. So if you want to do what I did here, which is to draw a line over the line of nodes on one side and then copy it over to the right, you can do that with the free version of the tool. And please check out my FAQ. I'll put a link to that. It's actually always in my description. It's at the very bottom. Answers a lot of the questions that people ask me all the time, so please check that out if you have any questions. Otherwise, if you have specific questions about what we're doing here, definitely leave those questions in the comments section down below. I pretty much answer all questions, guaranteed. And otherwise, leave comments on the video. I always appreciate that. I will see you in the next part. Select our target. And again, I don't recall which moon is the next one in. Let me see. There's Io, Europa. I think it's Ganymede. Is that right? Let me check. No, let's see. Yeah, Ganymede. So it goes Io, Europa, Ganymede, Callisto. So we need to target Ganymede. Okay, so select, bring an open IMFD course, target intercept, target the target body, Now for the fourth step, what we need to do, by default, when you bring up the target intercept program, it will find a solution for you. Now the important thing to realize is that the solution that it finds, while I do this, but I don't know if that would be interesting enough, where I bring up like a WordPad type of editor and I kind of outline, like what step one would be. Actually, I think I'll do that. Hopefully that won't be boring for people, but I think that having something like that will help people if they actually want to learn this process. So open IMFD, that's obviously number one. And then number two is going to be, let's see, we want the go to course and then target intercept. That's going to be step one. So let's put that in. Course, target intercept. And from there, we need to, and I thought one thing that would be fun to do would be to do sort of this moon hop series where I go from one moon to the next and use just IMFD. Now, this will be a little bit easier than it would be if I were, say, going from a moon of Jupiter to a moon of Saturn. That would have some different requirements. In this sense, we're basically, if you think of Jupiter as the sun, and then you think of Callisto and Callisto, Europa. I forget the order of the moons, but whatever. If you think of Jupiter as the sun, and you think of the four moons of Jupiter as planets, then in some sense we're just going from planet to planet, but the planets just happen to be relatively close together. So that's the idea, and I think it'll be fun. Let me go ahead and switch camera views here. By default, Jupiter doesn't have any bases on any of its moons if you just have Orbiter 2010. Okay, welcome to another Orbiter 2010 video. And this video is going to be the first video in a new series that I'm doing. I'm going to be going from each of the moons of Jupiter. Actually, let me say that a different way. I'm going to start off on Callisto, which is the moon that's farthest from Jupiter, and I'm going to hop my way down until I'm at Io. So there will be 4 different moon hops, and the idea, the inspiration or the motivation behind this video series is that I want to do everything with IMFD and not even look at transects. I think I now have a pretty good understanding of how IMFD works. Dimitri and I have spent a whole bunch of time recording that IMFD training series, and plus he spent some additional time with me off camera helping me out. So I think I've got a really solid understanding of IMFD at this point. But I recently made a moon package for all of the outer planets, and I'll put a link to those down in the description area below. So we now have bases that we can use as our starting and target points. So here on Callisto, I've just got this base set up, and I positioned this base purposefully so that we would basically be looking at Jupiter. And as I mentioned, I don't know if you saw that Jupiter moon video that I did that was only a couple minutes long. All of the moons of Jupiter are tidally locked, so no matter what time of year it is and no matter what year it is of the century or the millennium, we'll always have Jupiter in our forward view from this base. Okay, so let's just go ahead and get started then. And let's F8 over to the larger MFDs. They show up better in the video playback. And let's bring up IMFD over here. And I'm tempted to kind of almost do a like a documentation